Hello everyone. Today we are going to discuss about the combination of solids where we'll talk about how we can find out the surface area of it. In our last session of surface area and volumes we have discussed about the basic formulae related to the combination of solids or the individual objects which can be the cube, cuboid, cylinder, sphere, hemisphere. We have also seen the hollow cylinder and hollow hemisphere. Now moving towards solving the question based on surface area of combination of solids, let's discuss about first of all some of the basic type of object which we find in our day-to-day life while solving the questions. So here the different objects which will be coming in our examination will be these objects where we have the first one where we have a cube and here a hemisphere has been hollowed out from the top, whereas in the other case a hemisphere has been kept at the top covering some portion of the top surface of the cube. So let's understand how we can find out the surface area. So basic things we need to remember that whenever they ask to find out the surface area, we need to think that what are the surface after combining the solid will be still visible to us. We will have to find that surface area. So here in this case, if you talk about the first case where the hemisphere has been hollowed out, so in order to find the surface area of it, we know that a cube has 6 surfaces where 5 of its surfaces are without any change. We are only hollowing out the top surface. So in this case, the other surface area will remain same other than the top. So here, if you talk about the other surface area, it will be 5a square. Now when you talk about the top surface, so when you hollow out a hemisphere from the top, it will look as this figure where all the 4 corners will still be visible and then we'll have the curved surface area here. Now when we have to find out the surface area of it, so surface area will be equals to surface area of 5 faces of the cube, which will be 5a square, plus it will be area of top. Now when we talk about area of top, it will be the area of these corners, which will be here as a square minus pi r square. As we are hollowing out the top surface, we are hollowing out in the circular manner. So the top face of the cube will become a square minus pi r square. Whereas because of hollowing out, we'll have a curved surface area in it. That will be 2 pi r square. So when we add these two values, we will be getting it as a square plus pi r square. When we add it all, we'll get 6a square plus pi r square, where a is the edge length of the cube and r is the radius of the hemisphere. One more thing we need to remember here that in this case, the radius of the hemisphere will be equals to half of edge length. So we can say where r will be equals to a by 2. Now if you talk about the second case where we are keeping a hemisphere at the top, so in this case also if you observe, the 5 surfaces of the cube are without any change. Only the top surface we have to think about it. So in this case, the surface area will be equals to 5 surfaces area, which is a square, that is 5a square, then plus area of top. Now again in this case, if you see here, the top surface will look like this, where again we have 4 corners and then we'll have this particular surface. So area of this surface will be 2 pi r square and area of all the corners will be a square minus pi r square. Overall, the area of the top will be again a square plus pi r square. So the value of surface area in this case also will be equals to 6a square plus pi r square, where radius is again half of the edge length. Next, let's talk about some more objects where we'll see here a cylinder kept over another cylinder. So if we'll take the radius of the lower cylinder as capital R and the radius of the upper cylinder here is small r, then the area of the base will be pi r square. Area of this curved surface will be 2 pi RH, where h is the height of the lower cylinder and let us suppose h1 is the height of upper cylinder. The area of this circular path will be equals to pi external radius whole square minus internal radius whole square. Then the curved surface area of upper cylinder will be equals to 2 pi RH1 and the area of top will be equals to pi r square. So when you have to find out the surface area of it, we'll have to add all these areas. Next, when we talk about another case where a cone has been hollowed out from a cylinder. So in this case, if you talk about the radius of this cylinder, which is also the radius of cone, is r, then the curved surface area of this cylinder will be equals to 2 pi RH. The area of the conical region will be equals to pi RL, as it has been hollowed out and we know the curved surface area of cone is pi RL. Next, when we talk about the area of the base, that will be pi r square. So if you have to find out the surface area of this object, we'll have to add all these areas. The another case is from a cylinder, a hemisphere has been carved out from the top and bottom both. So in this case, if we'll take the radius as r and height as h, what we'll get is the curved surface area will be equals to 2 pi RH. The area of base will be equals to 2 pi r square and area of top will be equals to also 2 pi r square. So in this case, in order to find the total surface area of this object, we'll have to add 2 pi r square plus 2 pi RH plus 2 pi r square. Moving to the next combination where we have a cone kept over a hemisphere. So in this case, if we'll take, let us suppose the radius of this hemisphere and cone be same and it is r, and the height of cone be h and the slant height be L. Now in this case, if you have to find out the total surface area of this object, then we'll have to find the curved surface area of this cone, which will be pi r L, and we'll also have to find out the curved surface area of hemisphere, that will be 2 pi r square. So in order to find the total surface area of it, we'll have to add pi r L and 2 pi r square. And there will be other combinations also, which we'll see when the questions will be there. Before we start the questions, we need to know about some of the values, which we'll write it down here. The first will be the value of pi, which will be equals to 22 by 7 or 3.14. Until unless it is specified in the question, we are going to stick with 22 by 7 value rather than using 3.14. Next, we need to know is 1 cubic centimeter. If you convert it in terms of liters or milliliter, we can write 1 cubic centimeter as 1 ml, and here 1 cubic meter will be 1000 liters. And then another value is 1 hectare will be equals to 10,000 meters square. So these are some of the values which we need to remember. Now let's move to the question now, where the first question is, a toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of same radius. The total height of the toy is 15.5 centimeter. Find the total surface area of the toy. So here the total height is given 15.5. Let us suppose the radius will take here as r. So the value of r is 3.5 centimeter. And the total height of the toy is 15.5, whereas we know here the height of hemisphere part, that will be also r. So we can say if we'll take height of cone, it will be equals to total height, that is 15.5, minus height of hemisphere, which is 3.5. So that will be equals to 12 centimeter. Now we have to find out the total surface area of toy, for which we will be needing the curved surface area of hemisphere and the curved surface area of cone. And we know curved surface area of cone is pi r L. So we need to find the value of L first. So here L will be equals to a square root of h square plus r square, which will be 12 square plus this radius 3.5, we can write it as 7 by 2 centimeter also. So we can write this one as 7 upon 2 whole square root, which will be equals to 144 plus 49 upon 4. On solving, we'll get the value of it as 576 plus 49 upon 4, which will be equals to square root of 625 upon 4, and that we can write it as 25 by 2 centimeter. Now, the surface area of the toy, so we can write total surface area of toy, that will be curved surface area of cone plus curved surface area of hemisphere, which will be pi r L plus 2 pi r square. In this case, we'll take pi r common. We'll get L plus 2r, which will be equals to, now the value of pi will substitute it as 22 upon 7. Radius is 7 upon 2 into L, which is 25 upon 2 plus 2r, that will be 7. Now here we can cancel 7 and 7, this 2, we can cancel this 22 11 times. We will get 11 into 25 plus 14 upon 2, which will be equals to 11 into 39 upon 2, which will be equals to 429 upon 2, which we can write it as 214.5 centimeter square, which will be the value of total surface area of this toy. The next question is, a cubical block of side 7 centimeter is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? Find the surface area of the solid. So as we have already discussed that how to solve this type of question. Here they are asking that what is the greatest diameter. So here the greatest diameter is equals to edge length of cube, which is 7 centimeter. Therefore, the radius will become 7 upon 2 centimeter. Now here one thing we are going to learn, that we will try to avoid converting it into the decimal value, as it will be very easy while cancelling 7 when pi value is used. That is 22 upon 7, rather than using 3.5 and making the calculation a little bit lengthier. Now here, if you have to find out the surface area, it will be equals to 5a square, that is the 5 surfaces of cube plus area of top. Now in this case, as we know, the area of corners will be equals to a square minus pi r square, and area of this particular region, that is a hemisphere, will be equals to 2 pi r square. So it will be 5a square plus area of top will be a square plus pi r square. Now this will become 6a square plus pi r square. As we know, a is 7 and r is 7 by 2. We can write here 6 into 7 square plus 22 upon 7 into 7 upon 2 into 7 upon 2. Here 7 will get cancelled, 2 we can cancel it 11 times. The value will become 6 into 49 plus 77 upon 2, which will be 294 plus 38.5, which we can write it as 332.5 centimeter square. That will be the value of it. The next question is, a hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. Determine the surface area of remaining solid. So again, when we talk about this case, it is almost similar to the last one. Only the difference is here we are cutting out a depression. So here the value of A is equals to L, and so which is also the value of diameter. Therefore the radius will be equals to A by 2, that is L upon 2. Now the surface area of remaining solid will be equals to 5a square for 5 surfaces of the cube, and then area of top, which will be 5 into L square plus area of top will be the area of the corners will be a square minus pi r square, and area of the circular region, that is a curved surface area of hemisphere, will be 2 pi r square. So the value of it will become a square plus 2 pi r square minus pi r square will give pi r square. So this will become 5 L square plus L square plus pi r, we can write L by 2, so it will be L upon 2 whole square. It will be 6 L square plus pi L square upon 4. If you'll take L square common, this will be 6 plus pi upon 4, which we can write it as L square into 24 plus pi upon 4 square units. The next question is, a tent is in the shape of a cylinder surmounted by a conical top. If the height and the diameter of the cylindrical part are 2.1 meter and 4 meter respectively, and the slant height of the top is 2.8 meter, find the area of the canvas used for making the tent, and also find the cost of the canvas of the tent at the rate of rupees 500 per meter square. Here given that the base of the tent will not be covered with the canvas. So here the given values are, height of cylindrical part is equals to 2.1 meter, and the diameter of cylindrical part, if you say DCYL, which means diameter of cylinder, is 4 meter. Therefore, the radius of it will become 2 meter. In this case, also the radius of cylinder and the radius of cone is same, so we are not going to denote it by different symbol. For both, we'll use R only. Next is the slant height of the top is 2.8. So here L is given 2.8 meter, and we have to find out the total surface area first, for which we'll be needing the value of L, which is here. So total surface area of tent will be equals to curved surface area of cylinder plus curved surface area of cone. Now here curved surface area of cylinder will be 2 pi RH, which is height of cylinder, plus we have to take curved surface area of cone, which will be pi RL. Here we can take pi R common, we'll get 2h height of cylinder plus L. Pi value is 22 upon 7. The value of radius is 2 into 2 times height of cylinder, which is 2.1, plus slant height, which is 2.8. We'll get here as 44 upon 7 into 2.1 into 2, that will be 4.2 plus 2.8, which will be equals to 44 upon 7 into 7, and so the value of surface area will be 44 meters square. So this is the first part. Now we have to find out the cost. So here the cost of canvas will be rate multiplied by surface area. Rate is 500 rupees per meter square. So 500 into 44, that will be rupees 22,000. So we need 22,000 rupees for the canvas. Next question is, a wooden article was made by scooping out a hemisphere from each end of the solid cylinder as shown in the figure. If the height of the cylinder is 10 cm and its base is of radius 3.5 cm, find the total surface area of the article. Here the height of the cylinder is given 10 cm and the radius of cylinder, which will also be the radius of hemisphere, is 3.5 centimeter. So if we take radius as R, it will be 3.5, which will convert it into fractional value, which will be 7 by 2 centimeter, and height is 10 centimeter. Here total surface area of article will be curved surface area of cylinder plus 2 times curved surface area of hemisphere. As we are scooping out hemisphere from both ends, now the curved surface area of cylinder is 2 pi r into h, and plus curved surface area of hemisphere is 2 pi r square, so it will be 2 into 2 pi r square. It will become 2 pi rh plus 4 pi r square. Here we can take 2 pi r common, it will be h plus 2r. Now on substituting the values, we'll get 2 into 22 upon 7, radius is 7 upon 2, height is 10 plus 2r, which will be equals to 7. Here 7 will get cancelled, 2 and 2 will get cancelled. So the value will be 22 into 17, which will be equals to 374 centimeter square. That will be the value of it. This is all for this particular session. In today's session, we discussed about how we can find out the surface area of combination of solids. In the next session, we'll be talking about how we can find out the volume of combination of solids. Till then, thank you. Take care, everyone.